All right, so why don't I jump into our first talk. I'll be talking about XNAT, past, present, and future, including where we've been, the various things that got us to thinking about what XNAT should do, how we have built up the development effort, and how we've sustained it for the past 15 years. And then we'll talk a bit about where we are with XNAT and what's been in recent releases. Of course, there is still plenty of legacy baggage, and that's why we'll continue to be developing on XNAT. And I'll talk a bit about where we are on the roadmap. So XNAT got started back as early as 2001. I was working in Randy Buckner's lab at WashU. They had just initiated a large imaging cohort at the Alzheimer's Disease Research Center. Large cohort at the time meant we were going from studies of 10 and 12 people in kind of a typical cognitive neuroimaging study into dozens, and even thinking towards hundreds. And that was a longitudinal study, so we were seeing a couple hundred people coming in every year, and this meant that scanners were being used every day, and just trying to get the data off of the scanners and onto CDs and backed up was very awkward and time-consuming and error-prone. Getting quality control on the images was very sporadic because of the awkwardness of the CDs and just trying to even open the images, and getting the data processed in a very consistent way was difficult because we had no way to really control the various processing routines were being run the same way day by day. And this was leading to a lot of frustration in Randy's group. So he asked me, I had just joined the lab as a postdoc, to write some scripts that might be able to kind of help manage things a little bit better. Instead of writing scripts, I just started to build a web app, largely because I didn't really think I was going to stay in academics. And at the time, it was sort of like, the big .com thing going on. And I thought maybe if I learned how to write web apps, then I'd go join some big startup and everything would be super exciting. And then, of course, there was a .com crash, and I ended up staying in the lab, not just because of the crash, but because I was having a ton of fun with building what Randy and I decided to call XNAT. And Randy really was a visionary and committed. He was running a Howard Hughes Medical Institute lab and had some flexible funds, and committed those funds to starting to build the XNAT program. And we dedicated some of those funds to hiring the first XNAT developers, which were Tim Olson here and Mahana Ramaratnam, who we both hired about the same time. And it's an amazing thing to me that both Tim and Mahana are still working with me on the XNAT project. Kevin Archie joined soon later. Here's Kevin. Kevin was with the group for 7 or 8 years, got to be such a DICOM expert that he ended up leaving and has been a developer at Ambra for the past 8 or so years. And I think has joined us today as well. So welcome to Kevin. Always happy to have him on the back in the XNAT community. And really from the very beginning, we were open source. Randy was deeply committed to the importance of open source software and open data in science, and saw that by having an open source platform like XNAT would be a great way to promote open science and open data sharing. One of the kind of first real consequential programs we joined was the Biomedical Informatics Research Network, or BIRN. I think this is around 2005, and I have to say, like, any of these years take a little bit with a grain of salt because they're receding in my memory, and I'm estimating roughly when these things happened. But in joining the BIRN, we started to really kind of formalize what we were trying to accomplish with XNAT. And very quickly, we settled on a workflow that looks like this illustrated here. We're trying to capture data of different types, imaging being the focus, but realizing that linking it with clinical and genetic and behavioral and other kind of measurements was critical. And that in order to have quality data, it had to go through a somewhat of a formalized workflow that allowed us to manage quality, control who had access to it, support collaboration, and to support open public access when the time was right. This is a figure like we made very early on, and I still use it in almost every talk I give, 15 years later, because it's really still how we think about XNAT and how we think about, a productive research workflow. The burn itself was also kind of a visionary program. At the time, it felt a little frustrating because not everything we tried to do ended up working out. And I think that was partly because, to a large degree, it was kind of ahead of its time. We were building things that today you would build on Docker and other virtualization technology. We were doing things that really required much more hardware, more computing capacity. And so it was a little frustrating, but at the same time, all kinds of important things ended up spinning out of Burn. FreeSurfer was one of the main processing tools that was supported by Burn. 3D Slicer was a component of it. A lot of the methodology that was being developed to be able to image very large cohorts in controlled ways ended up leading to the ADNI, Alzheimer's Disease Neuroimaging Initiative, as well as the Human Connectome Project. XNAT was obviously part of that, but we were also working on various kinds of data standards and specifications, and the BIDS specification came as a fallout of that. And we really started working hard on how to formalize processing pipelines. And there were a number of pipelining sorts of tools that were being built within Burn, including Lonnie Pipeline and XNAT's pipeline engine. We then, starting around 2008, wrote the first independent XNAT funding, an R01 from NIBIB. We had 24 supporting letters, and that was a stretch to get all 24 of those. I think my mom and maybe my uncle or a couple of cousins helped throw in a couple of letters to get us that far. But we were starting to get adoption. A lot of those letters were talking not about how they were using XNAT, but how they imagined using XNAT. Going into kind of the next phase, we really solidified what the XNAT architecture and code infrastructure looked like. A big part of that was introducing the XNAT REST API. DICOM Web we were starting to tinker around with, but it took a little bit longer before we got all the way there. But we really did start building out a set of capabilities that allowed plugging in different kinds of data, different ways of visualizing the data, and thinking about how to analyze and report on that data. Over the next 5 or 6 years, we really built out the size of the XNAT team, and to date, we've had over 40 developers come through the computational imaging lab, where we host the XNAT development team. And where our origin was originally in neuroimaging, others outside of neuroimaging started to hear about XNAT. And despite the N in XNAT standing for neuroimaging, they started introducing the idea that maybe it would be useful outside of just neuroimaging. And at that first 2010 workshop, we had a number of groups coming and really thinking about how it could be used, particularly for oncology. I think that was the first time we met Simon Duran, who will be hosting the case study in an hour or so on using XNAT for cancer research. So over the, since 2010, cancer and a number of other biomedical domains have really been a big focus of what we do within XNAT. And it got to the point where we never spell out the XNAT acronym anymore. We just say XNAT because the neuroimaging really doesn't make sense anymore. It's just a fraction of what we do. About this same time, we founded Radiologics, which was a spin out from the lab that was really specifically focused on how to support groups wanting to use XNAT but needed an extra hand. Groups who wanted to use XNAT to run FDA clinical trials, which meant having to have 21 CFR Part 11 compliance, which is this whole set of requirements for data systems that are being used in FDA trials. And so we spun out Radiologics to support those kinds of use cases. About this time, Tim Olson, who had still been in the lab and was leading XNAT development, moved to Central Illinois and used it as an opportunity to join Radiologics full time. And Radiologics has been going strong and helping to support the XNAT community ever since. And a lot of fun activities have been happening at Radiologics. And while it supports commercial activities, the company has contributed back many features into the open source program. And I think to me is kind of a case study in how academic and industry collaborations can work. Also about the same time, the Human Connectome project started, and that really taught us how to scale up to very large imaging studies that we're doing, extremely complex imaging protocols. And through the Human Connectome project, we ended up sharing to date almost 2 petabytes of data through the XNAT Connectome database. We shortly after renewed that first NIBIB R01. This time we had 53 letters. All of these were much more committed that they actually used XNAT. It was quite a bit less aspirational and really described a platform that people were using and supporting hundreds of research studies around the world. And now, you know, to date, what things look like, we have a global user base across many biomedical domains. I've grabbed, you know, some of the logos of institutions that are using XNAT. This is by no means comprehensive. If you don't see your organization's name here and you'd like to be included when I do talks like this, drop me a line and maybe send me a little image of your logo, and I'll be happy to add you to this view. This you know, is really involved us partnering with many industry and academic initiatives. For example, we're part of the Quantitative Imaging Network within the NCI. We have supported, worked closely with NVIDIA to engage with their machine learning group. So there's just really a lot of ways where we've tried to be creative to expand the impact of XNAT and to make it usable to as large of a group of investigators as possible. About this time is when, you know, we introduced containerization within XNAT. I think Kevin was actually the first one to tell me about Docker, and he started to explore how we might be able to containerize scientific workflows. I think it was probably around 2014 or 2015. And I got super excited about it early. I think we were really one of the very first platforms that was using Docker type of technology to deploy containerized processing in ways that could support reusable science. Over the past 2 or 3 years, AI has really stepped to the forefront in driving a lot of the use cases around XNAT, in particular in pushing us to support very large data sets. You know, AI is hungry for data. It uses, tends in many cases to use retrospective data sets, so it's forced us to really figure out how to get big piles of data out of clinical packs and other clinical information systems and into XNAT. We work very closely with a company called White Rabbit that's been working on AI in breast cancer. They pushed us really hard thinking about how do we get literally millions of screening mammograms into XNAT in ways that could be annotated and processed through their training and inference algorithms. This has all led to you know, sustained growth of XNAT. I sent in the XNAT grant renewal this summer with 112 letters, and honestly, that was you know, thanks to many of you here on in the workshop today for contributing letters. I suspect we could have gotten more. 100 and something felt like enough to hopefully compel reviewers to understand the impact of XNAT in the community.
Dr. Dan, there's a question out here for you. Do you plan on supporting genomics data and synthetic data in XNAT for ML pipeline development?
Yeah, it's a great question. And you know, the answer is that we do support genetics some. You know, you can put some you know, small genotype sort of information into XNAT. I've always thought that it didn't make that much sense for XNAT to really be a genetics platform. It feels like genetics probably has a lot of its own sort of specific you know, processing, visualization kind of requirements. And I've always seen, kind of been waiting for some really good parallel sort of system like XNAT, but focused on genetics to come along that we could integrate with. To date, I'm actually not haven't seen anything, and I'm not terribly familiar with where we might go there. So it feels a bit still like an open-ended area, and one we have not cracked the code on. So if folks have ideas about it and want to grab a breakout room tomorrow in the poster session, I'd be more than happy to learn about it and hear what folks are thinking. So as far as where we are today, I'll go into some of these topics more specifically here in a couple of minutes. But just looking at the numbers, we have hundreds of installations around the globe. These numbers are hard to exactly assess where we are. We've had XNAT's been downloaded over 20,000 times. Sometimes I think that might be like the same lab downloading it 5,000 times, themselves. But because it's open source and you can grab it, we don't track who uses XNAT, and it can be hard to know exactly where it's being used and how it's being used. So I do encourage folks, if you haven't reached out to us to let us know you exist, definitely do just reach out and drop us a line. We're always happy to schedule a 30-minute sort of conference call to learn more about your use case and how we can help to support it. You'll see that and this comes from a survey that we did leading up to the grant, just kind of asking the community how they were using XNAT. It's still very widely used in neuroimaging, but also widely used for other areas, cardiovascular, whole body imaging, cancer. And I think what we find most is that as institutions start to adopt XNAT, they'll pick an area where they're most focused, but over time they start bleeding over into more and more use cases and expanding its use across their institution. But it's still the case that lots of XNAT instances are really about a single lab where there's just fewer than 10 users just working with their individual lab data. But they're, kind of the sweet spot is, somewhere in the order of, 10 to 100 users. So that to me represents something like an imaging center, and where there's maybe multiple modalities coming in and multiple research groups working with XNAT. And then finally, there's a very good chunk of the community that's using XNAT for very large systems, up to 1,000 users. And you'll see that we've had both steady growth of new people coming in and using XNAT, as well as groups who've been using XNAT for a long time, staying in the fold and continuing to use it, and in many cases contributing to the code base. This is a little bit of an elaboration on the kind of workflow that I showed before, just kind of digging in a little deeper into what XNAT supports. Really thinking hard about how to ingest data from multiple different modalities. We've always supported data coming over from the scanner. In more recent versions of XNAT, we've also been implementing interfaces to retrieve data directly from the PACS and support more streamlined web-based uploads. Moving on to curation, to me, this is really a key step where we can be building out more and more functionality to make it so when you have one of these huge cohorts, particularly those coming from messy retrospective data sets, that it can be reasonably organized. You can identify the level of quality of the images, figure out what kinds of scans are included in a particular exam, and generally just get it organized in a way that it can be used for big analyses. And of course, a big part of these big analyses is being able to annotate the images, and that includes being able to actually do region of interest and segmentations of the images, as well as to do more form-based kinds of annotations and labeling. And then obviously compute is a big part of it. We've been continuing to elaborate on the container service and integration with various high-performance computing environments, including Slurm. And as I mentioned, we've been working closely with NVIDIA to support the Clara platform and to generally support machine learning workflows. And then finally, moving actually into analyzing the data and publishing those data sets I'll talk a little bit more about that as the talk and the week goes on. So I'll kind of drill into a few of these points on data ingestion. This is what for folks who haven't seen it yet, what the interfaces look like for querying out to the clinical packs. For those who aren't familiar with the packs, that's the image repository used in the clinical environments to store all of the exams from patients coming into the hospital and the imaging center. So this interface allows querying into the packs by various metadata, finding lists of patients who match those search criteria, and then even putting in anonymizing or de-identifying labels for what those cases should be labeled as when they're pulled into XNAT. Once the search is done, you can submit it, and then XNAT's scheduling system takes over and starts to retrieve the images from the packs. But it does it in a way that complies with the rules set up by the clinical IT division, who are often very sensitive to potentially impacting performance on the packs. So for example, here's what a typical setup in our institution looks like. We can pull exams during the week at night, but not during the day, so that's grayed out. And then on the weekend, we have a little more latitude, so we can actually pull 2 streams of data all weekend long. And being able to show this kind of scheduling capability to the clinical IT group really helps to get their buy-in and comfort with us interacting with their system. The other thing that's really important in talking to a clinical IT group is helping them to get comfortable with patient identifying information. So XNAT's very scriptable anonymization capabilities, which allow in a very fine-grained way, both at a site-wide level as well as at a project level, to specifically indicate which DICOM fields should be removed or altered to maintain patient privacy. That's all scriptable and is automatically runs as the images are ingested from the packs and stored into XNAT. So it's a good and important way to provide some assurance that identifying information is removed. One of the things we've been working on, and this is implemented now in the web-based uploader, is the ability to identify when there's when there's identifying information burned into the actual pixels of the image, and to be able to black out those specific regions. So this is showing the uploader, and here I've selected a region of the image to black out. We've also been working on tools to automatically identify text in images and to automatically remove that text.
Dr. Marcus, we have a question for you. Is the DICOM Q&A native to XNAT? I don't recall seeing this feature within XNAT. Are you able to enable this feature for DICOM QR? And is there a way to anonymize ECAT files from XNAT?
The query retrieve is a plugin that I believe, and someone can jump in the chat and correct me if I'm wrong about this, but I believe it's shipping with XNAT 1.8 now, but it might be a separate plugin that you have to go and pull over. So someone jump in on the chat, but it is standard XNAT functionality at this point. And I think I saw something in someone asking about whether we can anonymize ECAT images. We do have a separate pipeline, as I recall, for ECAT anonymization, but I have to say it's been a very long time since we've dug into ECAT, and I'd be a little hesitant to say that it's ready to run. But reach out to us on the discussion group, and I think people who wrote that original anonymizer can probably comment on its state of things. Hopefully I got most of those questions answered. Some of them are coming in a little more detailed maybe than I can go into here, and we can take those offline to answer. Here's the kind of the standard interfaces in XNAT for helping to support data curation, just in particular for getting it organized and well labeled. one of the things that we've been working on is getting a better understanding of the diversity of how individual scans within an exam are labeled and how we can harmonize those labels so we can tell when two scans that maybe have a different series description are actually the same type of scan. So this is just a view of, I've gone into our packs, and I'll talk a little bit more about this tool, and Michael Heilman, I'm sure will be talking more about it. But this is a way to search for things in your packs by, here I've done modality of MR and looking for body part of head and brain. And when I do that, I get just a whole big pile of different series descriptions. Here's a list of counts, and this is against the packs here at WashU, where we have about 2 million exams. And you'll see that there's really, thousands of different series with hundreds of different labels. This page actually goes on and on quite a ways. So it's going to be very difficult to organize and understand what's actually contained in a cohort that you've extracted from packs. One of my students, Hussein Farashani, has been working on ways to automatically classify scans using both the header metadata and the image metadata to go from an unknown scan type into a standard scan class. We've been working mostly with brain scans to date, and have been working on ways to automate getting MR scans into standard BIDS classes. So things like T1W, T2W, FLAIR, BOLD, things like that, to do that in a consistent way that can then support downstream automated processing. And so, for example, when you run Hussein's classifier, you go from these generic series descriptions into these standardized classes. And then as you're doing things like using the container service, you can use these standard scan classes as a way to automate your processing in those containers. We've also are excited to implement more quantitative quality control regimes into XNAT. We've worked for a while with MRI-QC and also been working with the Marquee Group at Case Western, really to help drive, with clinical imaging in particular, where there's much less quality control up front in acquisition, to quantify the quality of images and then use those quantification ranges to, again, help drive automation and selection of cases. Moving on to annotation, there's obviously a lot of different ways to think about annotating images and different kinds of tools. One of the first steps, particularly in oncology, is to identify regions of interest and to segment out those regions of interest. And ideally, we'd have fully automated tools to segment images. Here's a segmenter that was developed in my lab for segmenting glioblastomas. Obviously, if you can do it fully automated, that's great. Sometimes you'll also have clinical segmentations that come from a treatment platform. And those can serve as useful regions of interest with very little manual effort. More often the case, though, I think, is that there has to be some level of manual annotation. And we've worked very hard, particularly in partnership with the Institute for Cancer Research Group and Simon's team, to implement annotation capabilities in XNAT's OHIF-based viewer. So here's how that's working today. You'll see a region being contoured. And this is actually pretty efficient. I'm able to do this, and I'm by far no expert in annotation. I can go through cases like this in just a couple of minutes and get a lesion or a body part contoured. And we'll have, I think, in the demo rooms in tomorrow's poster session, opportunity to see how this annotation tool works. So that's kind of manual. We've also been working with the NVIDIA group to use their AI-assisted annotation tool, where you can just very quickly throw down a couple of landmarks and let the assisted annotation use those landmarks to help guide the automated segmentation process. And that's built into the viewer now as well. Regions of interest, of course, are not the only way to annotate images. There's also need to label them and to complete form-based kinds of assessments. One of the ways we've approached that is to work with the radreport.org templating system, where you can define templates for different kinds of annotation protocols, and then you can use those protocols directly in XNAT just by specifying the ID for the template identifier on radreport.org. So that integrates directly. There's many standard forms already on radreport.org, and you can go build your own if your assessment isn't already there. This is an area where I think over the next year, we're going to see the most active development to really streamline annotation processes. We introduced the container service in XNAT about, I think, 3 years ago. And it's basically supplanted the old pipeline engine that was in XNAT from the very early years. It's much more agile, much easier to share things, much more efficient at distributing across computing environments. And importantly, the way we built the container service is you don't have to build a container specifically for XNAT. You can just kind of build a container as makes sense. And then XNAT's container service allows configuring that container to run in XNAT. So you just have to define what we call a command. And then that command, XNAT uses the information in that command definition to load particular images into the container and to run the processing with specific parameters. And then when the processing is done, to put the right images or output back into XNAT. And using the container service, there's many containers out there. So here's PyRadiomics, which is one we in my lab have deployed. There's also using Model Hub. Many people have shared different kinds of models that have been containerized. Any of these from Model Hub can be just dropped directly into XNAT just by setting up that simple command. And then you have that processing deployed into your XNAT instance. So it's really a pretty marvelous thing. This is a dashboard that we've built to really make it so you can scale out your container-based processing. Allows running very large batches and sequencing multiple different containers as you're working your way through those batches.
Dr. Dan, we have a few more questions for you. Does XNAT integrate with ARIA? Can we load outside segmentations from DICOM RT, radiation oncology into XNAT for review? What about Brooker files along with DICOM, NIFTY, TIFF? And then could you please give some comments on how XNAT supports studies in clinical trials versus studies in academic research?
Yeah, those are some good questions. Specifically on DICOM radiation type files. So we do support segmentation objects, RT struct. I think we'll probably hear more about that, and I'll let Simon elaborate on it in the case study later this morning. And we can certainly have a breakout discussion at the posters tomorrow. Non-DICOM format, obviously DICOM is kind of our favorite format because it does include so much metadata that we can use to help guide processing. But we do have various kinds of ingesters and import tools for non-DICOM images. We've worked with NIFTY for a very long time. We've worked with ECAD and non-imaging file formats as well. So things like ECOG and things like that. So some of that we already have plugins to support, and it'd be fairly turnkey. Other tools you'd have to maybe develop on your own, but of course the X and XNAT is for extensible and gives you the capability to add new importers into XNAT's functionality. And of course, I would encourage anyone who does that to share those back with the community. As far as clinical trials versus academic research, a lot of the workflows are very similar. The biggest difference, I think, with clinical trials is it requires more governance, more security, more auditing. And to a large degree, XNAT has basic functionality for that kind of out of the box. But if you really are using XNAT for an FDA trial or something that is an industry type of trial, that's where Radiologics has built the full Part 11 compliance and is probably the more appropriate platform to use. So I think in the interest of time, I'm going to kind of skip along here. We've worked hard to start supporting machine learning types of workflows. And this has meant adapting a lot of the core XNAT capabilities, like the container service and batch processing, to be more machine learning friendly. We had our first ML beta release about a year ago, or actually it was about a year and a half ago, I guess, and the first production release earlier this year. I think there's still a lot of work to do to get machine learning to work effectively in XNAT. But the first pass, we worked very closely with NVIDIA to support the Clara platform. Clara has a lot of nice things about it, including a library of pre-existing models that can then be fine-tuned with your own personal data. But Clara is just one of the machine learning platforms that's out there, and we do aim to be agnostic and supportive of a wide range of tools. Monai has emerged as a academic-oriented machine learning environment that we're very excited to be partnering with. But generally, a lot of the topics I already talked about with being able to annotate and curate data are the things that are going to make very large machine learning projects work. So I think XNAT's in a very good position to be able to support the workflows. But you'll see on the roadmap that we're going to be working hard on advancing XNAT's machine learning capabilities. Here's some of the models that are already in the Clara library. So these can be downloaded and deployed into XNAT for either fine tuning or for inference. This is what the interface looks like for the machine learning environment, where you can identify models of interest, start experiments for training, and then launch a live tensor board for monitoring the experiments as they're running. This is mostly fairly well documented at this point on the xnat.org website, and we've been building videos on the XNAT Academy training course to learn more about how to use the machine learning environment. So I encourage folks to take a look at that. So let's turn here in these last 5 or so minutes to some of the areas on the roadmap. And a lot of it is really embellishing on things that we already do, but getting much better at it. So as I mentioned, clinical integration is a really important part of how to get large imaging cohorts into XNAT. This is an interface that Michael Heilman and Woon-Chan Cho in the group have been working on. It builds on Kibana and Elasticsearch to index all of the DICOM metadata from a PACS and make that data searchable and filterable to at least start the process of identifying cohorts of interest. And it's built to scale. So this is an example pointing at the PACS here at WashU. You can see we have over 2 million patients and 20 million exams. And all of this can be searched on and be integrated to XNAT to have cases that have been identified, pulled from the PACS and into XNAT using that query retrieve interface I showed earlier. Image interpretation, obviously very important. Woon-Chan has been working on what we call the XNAT Rapid Reader. The XNAT interfaces were designed for navigating patient cohorts and finding data. They weren't built for doing rapid image interpretation. So the Rapid Reader is kind of a standalone interface where you can build work lists and quickly read through those work lists without having to navigate around the traditional XNAT screens and pages. So you can go through cases much more quickly and also do them in controlled ways that are managed by those work lists. Integrations are also a big part of what we've done in XNAT for a long time. We've worked with the 3D Slicer group, MITK, Osirix, others to be able to exchange data between XNAT and those platforms. I'd like to see a broader set of integrations built into XNAT. So just as an experiment, Woon-Chan and I played around a bit with integrating XNAT to Slack so that you can manage communication, discussions, tests and assignments through an environment that many of us are already using on a daily basis. And we're trying to really formalize a way to do these kinds of integrations in ways that allow many tools to just be easily dropped in. One of the common structures for doing this is a thing called webhooks, which I'd like to, we've started playing with, but are not quite there yet, but seemed like a very streamlined way to have things like Airtable and Typeform, Google Drive, and other environments which already support webhooks to be able to easily interface into XNAT. Obviously, security and access control and patient privacy and things like that become important topics when you start thinking about these kinds of integrations. Many of these platforms are more, facing out towards, non-clinical types of use cases. So patient privacy and HIPAA are not necessarily at the forefront of how they've thought about building their tools. And so that's an important thing to be thinking about, particularly because many of them are also cloud hosted. So that'll be one of the main things that we have to think about as we're expanding our level of integration. Integration also means being not just on the tool side, but also on the data side. So we've been working hard to expand the kinds of data systems that XNAT can share data with or get data from. One of the first things we've been working on is with the Cancer Image Archive. So working with that team, we can now, from XNAT, identify a cohort from a study that you can share directly at kind of a click of a button into TCIA. It doesn't show up automatically and immediately in TCIA. There is a sort of review process on their side where they curate the data and make sure that it's properly anonymized, but it does streamline the process of getting data to them. One of the things that we've played with for a long time in XNAT is being able to use Python and in particular Jupyter notebooks to interact with XNAT. We've had a Python library for probably a decade now that kind of serves as an SDK for working with XNAT data, but notebooks really add into that the ability to build interfaces in addition to basic scripts. So this is an interface that was one of the tools we used to annotate cases that have text burned into them. And this is, just a nice little easily clickable, viewable interface that can quickly be adapted by just going behind the scenes and playing with the code a little bit. We have some other tools that Misha Melchenko built for screening images and the series descriptions and for reviewing quality of image registration. But all of these, as built to date, require users to run their own Jupyter server. And one of the things that we want to do to streamline that is to integrate the Jupyter server directly into XNAT so that from a particular project, you can just launch a notebook. The data associated with that project will be in the context of that notebook. So the images and other files will be directly accessible. The list of cases and subjects within that project will be directly accessible. And from there, you'll be able to, in an easy way, run your scripts from the notebook, view output. And as you settle in on useful interfaces and structures for these notebooks, to be able to publish those to others so that they can use those same interfaces with their data. On the machine learning side, again, there's a lot to be done for supporting more streamlined annotation, running of experiments, monitoring the quality of the or the state of an experiment as it's running, and integrating with more different machine learning environments. This is a key part of the XNAT grant submission that went in this summer, which we'll be hearing about hopefully in a few weeks. And if all goes well, this will be a big part of the next 3 or 4 years of development. And final piece on the roadmap is spreading out into preclinical imaging. Folks have used XNAT outside of human imaging for a long time. But preclinical has its own sort of weird ways of collecting data. It's much less standardized than human imaging. The different scanners and devices are not necessarily DICOM native. There's a lot more kind of spontaneous imaging of animals. And so the workflows feel a little different. We have received NCI funding to build what we call PIXI, which I think stands for Preclinical Imaging in XNAT something. And this has been going for about a year or so now. Andy Lassiter and Koresh Shogi are helping to run that project. And I think we have a poster on that in the poster session tomorrow, and Andy will tell you a little bit more about it. So just a few other things real quick, and then I'll wrap up. As I mentioned, the renewal for the core XNAT R1 is out there now. But we do have substantial current funding while we're waiting for that funding to come in, including the U24 from the NCI, which supports our cancer-oriented imaging. That was just renewed this year, which we're very excited about. PIXI, as I mentioned, was funded in 2020. And on the radiologic side, there's a number of grant-oriented programs for continuing the open source support, including from the Templeton World Charity Foundation to support more lab notebook-oriented interfaces in XNAT, and a couple of SBIRs, small business grants, to support more intelligent anonymization. And by intelligent, meaning that it discovers when there's identifying information in the metadata and in the images. We've been working on that project for about a year now, and has another 2 years of work ahead. And then the NSF has funded a federated learning project, initially focused on COVID imaging, but we're expanding that to more generally supporting federated learning. That started in late 2020, and we're hoping to start phase 2 on that in the coming months. A little bit of other news, Radiologics recently merged with a company called Flywheel, which many of you are probably aware of. The public announcement for this will be coming out on Wednesday, so it's not a secret exactly, but has not been broadly broadcast yet, but will be imminently. I'm very excited about this. I think it'll increase the impact of what we're doing in the XNAT program, in particular, accelerating, expanding the feature commits that come from the commercial side. In particular, Flywheel uses the same OHIF-based image viewer and has been doing a lot of work on expanding annotation capabilities there. Similarly, they have a container-based processing environment that they call Gears, and I'm very excited to be able to leverage Gears that are built for the Flywheel platform within XNAT. And generally, I expecting this to really lead to more impact coming from the commercial side, and there'll be continuing commitment to supporting both academic research and the open source community. So very quickly, just want to introduce everybody from our team. Steve Moore is the XNAT project manager, program manager. Rick Herrick is our senior engineer. Dave Moffett has done much of the DICOM development over the past few years, and literally tomorrow is his last day of work before he retires and rides off into the sunset. So I welcome everyone to give Dave a hearty congratulations on his retirement. And if you happen to be in St. Louis Wednesday evening, we will be taking him out for beers. Will Horton runs a lot of our user interface and user experience work, and also hosts the XNAT Academy. Matt Kelsey is the containers guy, and definitely seek him out if you have questions about containerized processing. Chip Schweiss will be hosting the next panel, so you'll get to know him quickly. He runs all of our DevOps and IT infrastructure in the lab and has a lot of experience in running big XNAT systems. Yash is one of our coders. He's working a lot on the Python side of things. Andy Lassiter on Pixie. Charlie Moore knows the ins and outs of XNAT better than anybody and can tell you where all the bodies are buried. He does all of our testing and quality control and quality assurance. Michael Heilman has been working hard with Woon Chan on various clinical integrations and big data systems. He'll be talking more later today. And Woon Chan, of course, he's one of our wizard coders. So if something needs to get done in a brilliant and fast way, we go to Woon Chan. All right, so that is everything for me this morning. I know there were lots of questions that came in that I did not get to in the talk. I will address those separately in the chat, and we can put them up on our answers to these up on our wiki. So definitely keep the questions coming. If we aren't able to get to them in a session, we'll definitely get to them offline.